This is Jonathan Ellis. I'm a student at TTU in the ECE 3010 Signals and Systems class, and I'll be solving a magnitude and phase response question. The question we're given is, a filter has a magnitude and phase response as shown in the graph, and an input of x of t equals the cosine of 25 pi t plus 4 times the cosine of 50 pi t. Plot the magnitude and phase response of x and y. The first thing we need to recognize is that we have two frequencies. Omega 1 equals 25 pi and omega 2 equals 50 pi. The second thing we need to recognize is that the input signal is in the form of x of t equals a times the cosine of omega 1t plus b times the cosine of omega 2t. The third thing we need to recognize is that the Fourier transform is in the following form, which is long and drawn out and will probably give me a tongue tie me. The answer, though, I'll cover it, is x omega equals 1/2 times both of the delta functions, where delta is multiplied times omega plus 25 pi and omega minus 25 pi. And all of that is added to 2 times 2 delta functions. One of them is delta function times omega plus 50 pi, and the other one is the delta function times omega minus 50 pi. That's probably clear as mud. The magnitude response is the square root of a squared plus b squared, and the phase response is the arctangent of b over a. This is both for x, where x of t is a times the cosine of omega 1t minus theta plus b times sine of omega 1t minus theta, and that will give you the following graph. The magnitude response and the phase response of y is next. The magnitude response of y is the magnitude response of x times the magnitude response of h. And the phase response of y is the phase response of x plus the phase response of h. And that will give you the following graph. And finish the problem.